Welcome to the experimental aquaculture facility here at the Institute for Marine and Antarctic Studies, University of Tasmania.
Hi, I was wondering if you could please introduce yourself along with a little bit about your research.
Hello, I'm Chris Carter from the Blue Economy CRC, and I'm going to speak to you today about program number 2, which is seafood and marine products. Now what is seafood and marine products? Well, really it's about aquaculture, and it's about aquaculture in offshore environments. So our challenge in the Blue Economy CRC is to move aquaculture from coastal areas out into offshore areas, and that could be anywhere from 2 or 3 kilometres away to many kilometres into the seas. At the moment we're going to work on salmon and our established industries, but in the future we're really looking at something bigger than that. It's a really challenging and fascinating journey that we want to take, and we want to take it in a way that we will develop a new type of aquaculture. So an aquaculture that's going to be out there offshore and growing our seafood for us.
What is your research about?
Yeah, my research is about nutrition and physiology of what I like to term as aquatic ectotherms. So that's cold-blooded animals in old terms that live in the water. And I'm really interested in fish, and I'm really interested in crustaceans. So in terms of which bits of nutrition and physiology I'm most interested in, it's really about nutrients and understanding the efficiency of their use by the animals. So that's all kinds of questions to do with digestion, metabolism, meeting nutrient requirements, and really understanding how animals partition energy and use it and grow at maximum rates and with maximum efficiencies. So that's quite academic sounding, but in terms of practical outcomes and trying to relate that to aquaculture, it's really what underpins aquaculture nutrition, and being able to understand how to formulate feeds, and how you formulate feeds in terms of the nutrients that you put into the feeds, what are the correct amounts and ratios, and also which ingredients you can use, and are the minimums and maximums of ingredients. So by doing all of that, it helps us advance aquaculture nutrition, feeds, and making sure that those feeds are sustainable. This research program is very much about sustainable aquaculture research, and with the aim of producing seafood in a sustainable way. It's around making sure and future-proofing the seafood aquaculture industries for Australia and New Zealand, and it's really very much about supporting the existing excellent industries that we have in both of those countries. So at the moment, particularly about Atlantic salmon in Australia, king salmon in New Zealand, and some of the other aquaculture industries, including the Pacific oyster industry.
What are the goals and objectives of your research?
So if we talk about the goals and objectives of program 2, I think there are 2 really important words. So for me, sustainability and integration are the 2 key words that underpin this program. So in terms of sustainability, it's all around environmental, economic sustainability. And then when we talk about integration though, it's about integration at lots of different levels. So we're talking about integration of different species. So I've kind of talked about that in terms of having all of those different species as part of our system. But it's all around integration with the environment. So we need to be able to understand the environment and how that's going to interact with the animals and species that we're growing, and we need to be able to integrate that with the external system. But it's more than that. This whole Blue Economy CRC is around integration with other things such as the marine engineering platforms, the creation of sustainable energy that can be used, and it's also about integrating the people who are working there, so that we're making the best use of lots of people in this offshore facility. So integration for me is a really critical word, and it's got all of those different layers to it. So as well as moving offshore, one of the things that we need to look at is around integrating aquaculture, so actually growing more than one species. And the idea behind that is that we use some of the nutrients, again, we recycle the nutrients from one species to another species. So what do I mean by that? Well, for example, if we have fish and they produce some nitrogen, that nitrogen could be used by other species. So those other species might be seaweeds, or they might be phytoplankton, and the phytoplankton might be filtered by oysters. So you can grow other things, not just the salmon. And that's what we're trying to achieve, and we're trying to achieve that offshore. So I thought I'd try and talk about that in relation to how we're doing aquaculture at the moment, or one way we're looking at it. So here in this tank we've got some salmon, and those salmon are on what's called a recirculation aquaculture system, or RAS. So the RAS is there and it keeps the animals in water, and it cleans the water in various ways, and I'll show you those in a minute. So in this tank the salmon are being fed a known meal a couple of times a day, and that's obviously creating waste. So it's creating solid waste, lots of fecal material, and it's creating soluble waste, and that goes into the water. But we need to clean the water. So in this system we clean the water, and then we put the water back into the salmon tanks. So we recycle the water, but we don't recycle the nutrients. So I'm going to show you some of the facilities here, and they're just for cleaning that water so we can recycle it. So we'll just pan around and have a look at that. So if we can get our integrated system to work, we can find a way of recycling those valuable nutrients and recycling them so that we turn them into other seafood products. So from, say, salmon in a cage, we might have seaweed surrounding that, and there's lots of different products that you can get from seaweeds. We might have filter feeding animals, so oysters for example, which are living on phytoplankton, and we might have other animals that actually live on the seaweeds. So we might have abalone that graze on the seaweeds, or we might have rock lobsters there. So you can see we're building up an ecosystem around the nutrient generating salmon in the middle of that. So it's really exciting in terms of lots of different seafood. But another thing that's very important is that we're actually trying to make the system sort of independent from the environment. We're trying to make sure that the nutrients stay within our system even though it's offshore.
What other researchers or institutions do you work with?
Some of our collaborators that we're really excited to be part of the Blue Economy CRC are the 3 Tasmanian salmon companies. So we've got Tassal, Huon Aquaculture and Petuna. As well as that, we have a Tasmanian-based international feed company called Skretting, and they're going to be assisting in us further understanding the nutrition. In New Zealand King Salmon is a partner, so we've got the King Salmon and the Atlantic Salmon covered in the CRC. And some of the other organisations that are part of this are CSIRO, as well as Food Innovation Australia Limited, which is all about understanding the products that come from, well, food, agriculture, food, but for us, from seafood. So we've got a great range of government and commercial partners, and they sit alongside our research institutions, the universities that are part of the Blue Economy CRC.
What is their expertise or experience that they bring to this area?
So who are we collaborating with? Well, one of the great things about the Blue Economy CRC is exactly in the name, Cooperative Research Centre. So really one of the exciting components of being in a CRC is that you've got lots of people that you're working with. We've got many different organisations as part of the CRC. So in my program we're going to be working with people who are in the industry. So the aquaculture industry, salmon farming, oyster farming, And they have fantastic knowledge in their industry. They have real experts. They have people who are researchers, people who are applied researchers, and they are the people who are actually going to help us define and understand what the problems are. But more importantly, they're actually going to be able to do a lot of the work with us to understand what the solutions are. And because we're working with industry, those solutions will be kind of immediate and practical and transferable to the industry. So we are expecting to be able to identify the critical questions that we need to ask and get the solutions worked out in a way that can be transferred easily to industry. So as well as industry though, we have a fantastic range of researchers, people who have researched all kinds of aspects of biology that are related to aquaculture, to the environment, and the actual production of seafood, the actual ideas about the quality of that. So it's a really fantastic opportunity for kind of new thinking. So that new thinking will come out of making new collaborations, and that's one of the reasons that as a researcher I'm excited about being part of the CRC.
What made you interested in this field?
So when did I first become interested in this topic? Well, I think really I've always been mostly interested in biology. It was my favourite subject at school. And when I was looking at what to study at university, it was the year that Life on Earth came out. So the famous series by David Attenborough about living things. And I just loved that series. It just made sense to me, and everything seemed to have a type of organisation. I read the book over Christmas, and following that I decided I'd study zoology at university. I do remember though shouting a lot at Sir David on the television because he didn't quite go far enough. I wanted to know more about the things that he was telling us on that programme. So I think David Attenborough and Life on Earth was really what steered me into doing zoology.
What study, activities or volunteering did you do to get where you are?
So what were the steps? Well, I followed a very traditional academic career of doing a first degree in zoology, doing some marine biology, doing a PhD, and that was where I started to become interested in aquaculture. So the species that I looked at for my PhD is a species called grass carp. And grass carp, as you might guess from the name, is a herbivorous fish, and that's relatively unusual. And as well as being interesting just because they're herbivores, they happen to be the most produced fish in aquaculture in the world. So Chinese aquaculture uses grass carp extensively. So that kind of started making me think about aquaculture. And my next job, or my first job after my PhD, was at Aberdeen University, where I worked on salmon. So it's the first time I'd worked on salmon nutrition, and that kind of helped me learn more about aquaculture. Scotland's one of the countries for the production of salmon. And then I made a kind of big decision. So as part of, thinking about your career, sometimes you have to make a choice. So my choice was to do less academic work and perhaps focus on applied research. And so I decided I'd come to Australia, I'd come to the University of Tasmania, and I took up a lectureship in aquaculture nutrition, which was very much an applied position, looking at working with the industry here and looking at feed development. And it kind of kept going from there. So after a few years and a lot of hard work, I ended up being Professor of Aquaculture Nutrition.
What does your day-to-day life look like while working and researching?
Yeah, good question. So what does my day look like? Well, it's hard to say really. Some people might look at me and think I just spend all of my days staring at a computer screen. But that's only the surface of it, because my world in a way is partly behind that computer screen. So it's all about reading academic material, thinking, writing things. So that's one component of it. And I've always enjoyed writing about what interests me most. But other things that happen, of course, I work a lot with research students. So it's always exciting to talk to research students, have meetings with the other supervisors, and get a real sense of the discoveries that they're making and the pathway that they're on. So that's one of the highlights for me, is seeing the research that's been done by the students. One of my big pieces of work at the moment is to be part of developing rock lobster aquaculture with a fantastic team, which is both scientists at IMAS and a commercial company based in Tasmania. So we're the only place in the world that's actually making headway in terms of a sustainable rock lobster aquaculture industry. And that's really exciting to be able to spend a lot of my week on a specific project working with a really informed, energized team trying to solve a real problem.
What advice do you have for aspiring scientists and future engineers?
Can I give you any advice? I'm not sure. I'm getting towards the last half of my career now, and things have changed a lot. I had a very traditional academic pathway. I'm sure I can come up with some pieces of advice though. So I think one of the real pieces of advice I can give is always listen, always look, always be open to new experiences and learning. I always think you can learn something from every experience that you have, and then try and incorporate that learning into a kind of vision that you have. So my other piece of advice would be work out what your vision is for what your life should and could be, and then plan it. You know, have a plan that helps you achieve that vision, but don't be rigid, but also be flexible, adaptive, look for new opportunities, look to slightly different pathways where you can still stick to your big vision, but change your plans maybe. So be flexible is another piece of advice. But I think also though, understand where you're coming from. So I think if you work out what your values are, and always stick to your values, so you have a kind of core place to work from, so you understand why you're doing things, you know, what your vision is about, what you will and what you won't do. So another piece of advice then is really be clear about what your values are. And of course they'll evolve, but it's important to have those as being central to you. And leading on from that, I think as scientists and engineers, we have to be advocates for science. We have to be advocates for this kind of scientific method, the approach. And that's quite hard in this world at the moment. You know, there's a lot of people who are apparently expert about things without knowledge. So part of being a scientist is to believe in the process and really believe in knowledge-based decisions and to believe in facts and to basically be an expert and be able to defend, you know, your opinion because it's going to be based on knowledge and facts. So that's one component. But the other exciting and challenging thing about science is that, of course, it's always evolving. So it's always questioning itself. And I think that's a bit that is perhaps harder for non-scientists to understand. Where people expect there to be a right and a wrong answer, part of science is, you know, refining the answers. It may even be turning the old answers on their head and coming up with a completely new answer. And that's part of the great thing about science. So if you're going to be a scientist or an engineer, you be an ambassador for doing science properly and, you know, basing what you say on facts and really advocating for the scientific method. So thank you.